Hey guys, let us do this. It says the integral from 0 to 1 of x squared minus 1 over ln x dx. So we have to integrate this, and it would be easier if we didn't have the ln x at the denominator here. So how can we actually do this? We can do this with what's called the Feynman's technique. The Feynman's technique allows us to take a function inside or make a function inside of the integral and differentiate the integral in respect to that function. So this is what the Feynman's techniques is all about. It says we can say this is the integral from 0 to 1 of x, making this to be minus 1 over ln x dx. So we make I of b that function. So if I of b is the integral from 0 to 1 of x to the b minus 1 over ln x dx, then this integral, the initial one, the initial integral should be equal to I of 2, right? Yes, because we made 2b here. So b is now the function. So we have to differentiate this integral in respect to b. So if we are to do that, we differentiate both sides. So differentiating this, we have I prime of b to be equal to the integral from 0 to 1. Differentiating this in respect to b. Differentiating this in respect to b, we have x to the b ln x. Differentiating this in respect to b, we have 0. But don't forget to put this at the denominator. Differentiation allows us leave the denominator if it is a constant. So this is our dx. So now we notice that these cancel out easily. So we have our I prime of b to be equal to the integral from 0 to 1 of x to the b dx. So we can integrate this, and if we integrate that, we have our I prime of b to be equal to, integrating this is x to the b plus 1 over b plus 1. So putting x as 1, we say 1 to the b plus 1 over b plus 1, and that is just 1 over b plus 1. Putting x as 0, the other one becomes 0. So our I prime of b then becomes 1 over b plus 1. So we are not to find I prime of b, we have to find I of b. So our I of b then becomes, integrating both sides, we have our I of b to be the integral of this. The integral of this is just ln b plus 1 plus our constant c. But we have to find our constant c since we are dealing with a definite integral. So in finding our constant c, we know our I of b is this and our I of b from here is this. So why not equate both? So we have that our integral from 0 to 1 x to the b minus 1 over ln x dx is equal to ln absolute value of b plus 1 plus c. Notice something, when I input 0 as b here and do the same at the right hand side, we have that x to the 0 is 1. 1 minus 1 is 0. So this whole integral becomes 0 because 0 over ln x is just 0. So the whole of this integral becomes 0. So the left hand side becomes 0. And when I input 0 here, it becomes 0 plus 1 and that is 1. So ln 1 is just 0. So this is also 0 plus c. So therefore our c then becomes 0. So from there that our c is then 0, our I of b is equal to ln absolute value of b plus 1. But actually, from the main integral, which says the integral of x to the 2 minus 1 over ln x dx from 0 to 1 is actually I of 2 and not I of b. So we have to look for I of 2 and not I of b. So instead of I of b, then our I of 2 becomes ln 2 plus 1, and that is just equal to ln 3. So our integral from 0 to 1 of x squared minus 1 over ln x dx is equal to ln 3.